Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. I have two questions for you. One, have you asked why it is possible to use straw for drinking minerals? Two questions. The second question I want to ask you is, why do we always hang water tanks on the top? Answers to these and many more questions will lead us to the topic titled Pressure, Part 1. By the end of this lesson, you should be able to define pressure and its concept, differentiate between pressure of solid and that of liquid, state and explain properties of pressure in liquid, then state Pascal's principle and its application. Give a mathematical representation of pressure and solve a few questions on pressure. Watching the screen, you will notice metal squashing some kinds of coconut. Yes, somebody will say that it is a force that was applied, but it's not just about the force applied as the body was coming down, pressing down this coconut. It's about both the force that was applied and the surface area where these coconuts are placed. And this is a very good example of what pressure does, especially the one we call solid pressure. It is a force per unit area being applied on a given area at a particular time. So pressure can be seen in different areas. Like we have pressure in solid. It's not as the same pressure as the one we have in liquid. And also it's not the same pressure of the one we call gas pressure or atmospheric pressure. All these are different pressures and they have different way they act. But one thing is common amongst them all, that there is a force applied in different ways. Now, the pressure and its concept. Pressure is a force per unit area, or you say that pressure is a force acting perpendicularly, and that is why I highlighted that word, perpendicular force, and normally, which is called perpendicular. That means acting at angle 90 to a unit area, especially when we talk about solid shape, solid pressure in solid. And according to the relation is force per unit area. And the SI unit of pressure can be Pascal or Newton per meter. And we said that it can also be measured in atmosphere, such that 1 atmosphere is 1.01 times 10 raised to the power 5 Pascal. And then pressure is a scalar quantity. So not most of these quantities that are really mistaken as vectors just because of the presence of a force is not. So it's stated clearly pressure as a scalar quantity. Now, pressure in solid and that of in liquid, like I said before, pressure in solid and that of liquid are quite different in practice. They are quite different in practice. Even the use of formula, we differentiate them based on the parameters to be considered when you're talking about pressure in solid and that of liquid. Now, solid pressure involves force applied on a given surface area. So there must be a given area, a specified area where this force is going to be applied, and that force mostly goes downward. So like the clip of video you watch on the introductory part of this lesson, you saw a body coming down and pressing down some coconut. That means solid pressure consider the area and the force and mostly goes downward. But when we talk about the liquid pressure is characterized by the density of the liquid, the height or the depth of the liquid, and then you talk about acceleration due to gravity because of its direction of operation. And also the pressure in solid it's exerted in all directions. However, like I said earlier, the pressure of a liquid is about the depth. The depth, that is why when you see tanks, a tank of water is always hung on top in order to give a high depth for the pressure to gush out immediately you turn on your tap. So that is the difference between the liquid pressure and that of solid pressure. Now we have a very simple example here to solve concerning pressure. It said a force of 40 Newton acts on an area of 5 meters square. It said what is the pressure exerted? So in this case, pressure is force per unit area, and the force given there is 40 and the unit area is 5. And at this point you have that pressure is 8 Newton per meter. Now also we have a piston, like this is a piston. This is a very good example of a piston. Now we have it here. In this case, said a piston has a diameter. Remember, a diameter, when we talk about a diameter, we are considering a circular surface, and that means the area of application of the force is a circular surface. So we look at the diameter to be 0.2 meters, right? So the diameter is 0.2 meters, and it is subjected to a force of 200 Newton. It is subjected to a force of 200 Newton. Then they say, what is the average pressure on the piston? And they say we should take pi to be 22/7. To be able to solve this problem, we have to first state the relation for a pressure, which is force per unit area. Now, in this case, the area is a circular object, and then that means we are going to use the area of a circle, and the area of a circle in this case is pi r squared, because we are given a diameter to be 0.2. Now, if you have a circular part, and then this is the center of the circle, the diameter is from this part, let's say point A, to this point B. Now, if from here to here is 0.2, then what will be from this part to this part, which is the radius? It is going to be, radius is diameter divided by 2. So when you divide diameter by 2, you have the radius. Now, in this case, 0.2 divided by 2 is going to give us 0.1 meters. Therefore, the radius of this circular piston is going to be 0.1 meter. And I continue going and put down these parameters on this relation given. So the force is 200 Newton all over pi is 22/7 times r is 0.1 squared, because the r is squared, and that is why 0.1 is also squared here, and the pi is there, 22/7, which is approximately 3.124. So if we do our simple calculation, we're now going to have that we are going to have that 200. Okay, first let's bring this down. So we have 200 all over 3.142 times 0.001. 200 3.142 multiplied by this 0.1 square is 0.01. So when you multiply that with 3.142, we have this as 0.03142, then divided by 200. So we said that the pressure exerted is 64. I can say it's Pascal. So 6410.3 Pascal on this problem. So you always consider the object given, the piston and the diameter, and that led me to be using this area, which is pi r squared, because it is a circular object. When we talk about pressure in liquid, we are considering this height, G, and this density. Now, everything has a reason. But remember that when we talk about pressure, generally pressure is given as force per unit area. Now, when we are considering this force, we can also say that force which acts downward is given as mass times acceleration due to gravity, and that force can be regarded as the weight. So if I have mg at this point all over area, when we talk about area, what are we talking about? Remember that area came from a volume of a body, because we say that the volume of a body is area times length or height. So area in this case is going to be volume per height. So I'm going to have, instead of writing area here, I'm going to have volume divided by height. All right? Now, if I go further, I will also say that the mass, this mass, considering that we are dealing with a liquid, that mass came from the fact that volume, density of a body, which you've learned in previous class, is mass per unit volume, right? So that mass is going to be density times volume. So I'm going to have this density times volume and acceleration due to gravity, and is given divided by V all over height. All right? Therefore, we say that pressure, this implies that pressure is given as the density of the liquid, volume of the liquid, acceleration due to gravity times height all over V. V cancels V. We say that pressure is given as density of the body, acceleration multiplied by acceleration due to gravity and height. And remember that multiplication is commutative. So everything here, it doesn't matter how the parameters are arranged, but you can notify that this is the density there, and this is acceleration due to gravity, and this is the height of the depth of the liquid, as the case may be. Now, which is fully represented. So a few of these questions can be solved when we start using our Examguide app. You will see how these are really done in many of our exams like WEAC and JAMB. Now, what I have just said about pressure in liquid is demonstrated by this video clip you're watching. Now, if you look at this could be represented as a tank or any object filled with liquid, especially water, which is a paramount or universal substance, we all know. Now, we have different points on this tank. Point A, point B, point C, and D. So I can even have this point, I can call it point E. Now, what are you going to say concerning the pressure of the liquid falling out or gushing out from point A, gushing out from point B, C, D, and E? You realize that as the depth is going down, as the depth is increasing, you realize that the pressure is getting higher. The one at the beginning, at the toppest part of this place, remember the depth is, when we are talking about depth is not the same thing as height. In reality, depth is not the same thing as height in reality, even in mathematics. When we are talking about depth, we are talking about from top, you go down to the bottom. But when we are talking about height, we are talking about you starting from the bottom, you go up. Now, the pressure at this toppest top, you see that the way the water is gushing out is very weak. That means the pressure here is not strong enough. But the pressure at D is stronger than the pressure at this point. The pressure at C, based on the way the water is gushing, is stronger than the pressure at D. The pressure at B is much better than that of C, and the pressure at A is far better because you see the way it is going there is far more than the pressure at B. And this leads to the conclusion that the pressure in liquid increases with depth. So if you are going from top to bottom, the pressure is increasing, and that is how. And that is why sometimes when you open a tap, you see the way the water gushes out based on if the tank is fully filled with water. And it doesn't happen the same way when the tank is not filled to the brim. So it's all about the depth of the tank. Now, when we're considering the properties of liquid pressure, we say that increases with depth, just like I explained, looking at this body. The one at the bottom, which is point A, the pressure is much more than this one at this point. Now, at any point at the same level is the same in all directions, irrespective of the shape. So, what we mean is this. If this is a container filled with so at this point now, this is a container filled with a liquid. If I have any point at point A, point B, point C, point D, and let me draw a line to represent it. The pressure at this point is the same. That is why I said pressure at any point at the same level. So let's look at this level at where the pressure at point A, point B, point C, point D, lying on the same level. They say they are the same irrespective of the direction or the shape of the body. So that is what the liquid pressure is all about. And lastly, you say that it depends on the density of the liquid. So the pressure depends on the density. Remember when we studied density? So pressure is a function of density. Now we have a question here for you. A cylindrical tank is 30 meters deep. Calculate the pressure exerted at the bottom of the tank when it is 4/5 filled with water. Acceleration due to gravity is this, density of water. All right. At this point, I want to recall your attention that pressure is density of a substance, height, and acceleration due to gravity. And on this note, we have that the depth is represented by this height. But then it's not just about the height, because the tank was not totally filled to the brim. So it was filled a fraction to the top or to the brim, and that is 4/5. So this height is just going to be 4/5 times height times density, acceleration due to gravity, and times density. So the pressure is 4/5 times height is given as 30 times acceleration due to gravity is 10, and then density is the 1000 because it's water. So density is 1000. So at this point, this is 6. We have this, which is 240 and Newton per meter square. Newton per meter square. Yes, Newton per meter square. And this is the pressure according to this question. All right, we also have another one. We said that a rectangular tank contains water to a depth of 2 meters. If the base is 4 times 3, calculate the force on the base and density, the same problem. But then at this point, we are looking at, okay, so we are still going to go with, the base is 4 times 3, and that is the area. So base times breadth is the area, and the force on the base. So we are looking for the force. So we are given density of water and acceleration due to gravity. Okay. Now, pressure is still the same thing as force over unit area. Remember, But then we have to find the pressure because we are not giving pressure. But what you are looking at this point is the force. But remember that pressure is height, acceleration due to gravity, and multiplied by density. And the height in this case is 2, and density of water is there, and acceleration due to gravity. So pressure is 2 times 10 times 1,000. And the pressure is given as 2,000 Newton per meter square. Then, how then do we find the force? Yes, the force is, and this is going to be 2,000, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, okay? That is 20,000, 20,000. Then 20,000 is going to be, force is what I'm looking for, all over area. Area is going to be 4 times 3, 4 times 3, because area of a body is length times breadth. And the length and breadth, according to this rectangular tank, is 4 times 3, which is 12. So the force is going to be 12 times 20,000. And the force is going to be 24 Newton. That is 240,000 Newton is going to be the force on the tank according to this question. Pascal's triangle, Pascal's principle, pardon me. Now, Pascal's principle says that the pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. Now, this is, looking at this picture, a force is applied, a little force is applied on this piston with a small area. And inside this hydraulic press or car jack is fluid. Now, according to what Pascal is saying, he says that when this pressure is applied through force, remember that whenever we are talking about pressure, there is an application of force. Now, that when force is applied, that the liquid in this place does not diminish, and that is why it is able to carry a heavy body like a car and lift it up, because this liquid is pushed down. The more you push the piston, the lower it goes, and the liquid cannot lose it and then push this one upward. Then it was able to carry this. So that is why I said to every portion of the fluid and the walls of the containing vessel. Now, looking at this, also, these are a few applications of the Pascal's principle. What I explained in the previous slide is what you are seeing here. Looking at this one carrying the car first, look at it. Now, you also know that the application of Pascal's principle are seen in the hydraulic press, which some people call the car jack. And looking at this, when a little force is applied here, the car is lifted, undiminished. And that is why it can carry the car as long as it goes. And this is the one we call the hydraulic press. And you keep watching that, you see what's going on there. All right. Now, the second application of Pascal's principle is seen in a motor car foot brake. You see that? A force is applied through this means, and then the fluid inside here goes down, transferred undiminished, because the principle is that the fluid where the force is applied is undiminished, and it follows through these tubings, goes down here to clip the tires. And that is why you are driving at a point, you apply a brake, and the motion of the car comes to a halt. And these are very good inventions that came from what Pascal stated about fluid pressure. Now, let's look at the hydraulic press. Before we go into that, remember what we just watched. This one is hydraulic press, and this is also hydraulic press. Now, you remember that we have two areas, this area and the bigger area. So there are two areas and two forces. The area of this, the circular area of this part, and the force applied on this small area, and then the area of this bigger part and the force it is used to carry this car. These are the two major conditions you have to consider in talking about the hydraulic press. Now, the pressure in hydraulic press is seen on this question. He said, in a hydraulic press, a force of 15 Newton is exerted on a small piston of area 0.025 meter. The large piston has an area of 0.50 meter square. They say 1. Calculate the pressure exerted on the liquid by the small piston. Okay, if you look at the pressure, the small piston is a surface area where we have a force of 15 Newton and force of 15 Newton on the small piston and the area of this. So the pressure on that place for number A part is going to be, pressure is force over unit area. So the force there is 15 and the unit area is 0.025. So just use your device, and that is 600 Newton per meter square. So that is the pressure on the small piston. That is the pressure where the small piston, like what's here, that is the pressure this small part is exerting on the fluid in this hydraulic press. So let's go back. Now we say the pressure exerted on the large piston. The pressure exerted on the large piston. All right. On the large piston, it does not. They didn't tell us the force on the large piston, but something has to be done to be able to find the force before we can find the pressure. Now remember what I said earlier. I said that the pressure, according to the condition of pressure, according to condition of pressure in liquid, look at what it said. It said, at any point at the same level is the same in all directions. So the pressure at any point in the same level is the same throughout. Now, that means the pressure on this part must be equal to the pressure on this part because they're on the same level. So having this at the back of your mind as a principle, let's go back to solving this problem. And that means that the pressure, which is F1 over A1, that is the pressure of the small piston, must be equal to, let me use S as small, force of the small piston, area of the small piston, is equal to the force on the larger piston, yes, all over area of the larger piston. So the force on the small piston equals the pressure on the small piston equals to the pressure on the large piston. With this, we have that the force of the small piston is given as 15. So everything here is 600. Yes, because 15 over 0.025 is that. Then I don't know the force of the large piston, but I know the area, which is 0.5. Yes, 0.5. Then force on the large piston is this, 600 times 0.5, which is giving you 300 Newton. So 300 Newton is the force on the larger piston. That is the force on the larger piston, but that's not the pressure on the larger piston. Now the question is, what is the pressure exerted on the large piston? To be able to do that, we use this formula because the pressure on the large piston is the force on the large piston all over the area of that piston. And then this is going to be 300 all over area of the large piston, which is 0.5, which is also going to be 600 Newton per meter square. Remember what I said? They are the same. Now, we also said that the force exerted by the large piston on the load, and that has been already found to be 300 Newton. We have come to the end of this class, but before we go, let's take some exercises from Examguide app. All right, this question, let's look at it. It said, a plank is placed along the path on which a wheelbarrow containing sand is pushed at a construction site to prevent it from sinking as illustrated in the diagram above. The large area of the plank prevents the wheelbarrow from getting stuck by dash. All right. This question is application. Let's look at how we can get the answer. Number one, the first one they said their option A says increase the reaction on the ground. Increase the reaction on the ground. Does pressure have anything to do with reaction from the ground? No. Pressure does not have anything to do with reaction from the ground. I know that reaction is force. So, but that's not the intention. That's not the reason why that plank was placed there. No. Now, increasing the pressure on the ground. No. Decrease the pressure on the ground. Okay, look at this relation. I want to explain this with this relation. Look at this. If for this wheelbarrow to be able to be stuck, then the pressure of the wheelbarrow must be reduced. And what is that plank doing? The plank is providing an area. So the force or the weight of the wheelbarrow all over surface area or the unit area. The unit area in this case. Now, remember this. According to this relation, which is the general relation of a pressure, as the area is decreasing, pressure will be increasing. Now, in this exercise, the intention is not to increase the pressure. However, if I also say this, that increase the area is to reduce the pressure. So, when the area, that is the plank, they brought the plank in order to increase the area. When they increase the area, the pressure must be reduced. And if the pressure from the wheelbarrow is reduced, then it cannot be stuck on the ground. Therefore, decreasing the weight on the ground, no. Decreasing the pressure on the ground should be the best option. The pressure on the ground is reduced because the wheelbarrow is mounting pressure on the ground. And to reduce the pressure on the ground, they increase the surface area where the wheelbarrow is pushed through. And that is by using this plank to increase the area. So as the area is increased, the pressure is reduced. So this is the option. And that option is to decrease the pressure on the ground. Okay. Now, this question is about hydraulic press. In a hydraulic press, a force of 40 Newton is applied to the smaller piston of area 10. Remember, the force of the small piston over area of the small piston must be equal to the force of the large piston over area of the large piston. Sometimes, some textbook they will use F1 over A1 equals to F2 over A2. So whichever you choose, it doesn't matter. Now, they say if the area of the piston of the larger piston is 200 centimeter square, calculate the force obtained. All right. In this case, I'm going to use my favorite. So the small force is, small piston has 40 Newton and the area is 10 cm square. And the bigger one, I don't know, which is F, all over 200. Remember, if I have cm square, they will cancel themselves. So it's not an issue. So if I clear the fraction, I have F multiplied by 10 is equal to 40 times 200. If I divide both sides by 10, say F is this, which is this is 8 Newton. That is 800 Newton. Do you have that option? And that is option A. Okay, we go to the next one. This is this. Okay. All right. The pressure in a liquid A is the same at all points in the liquid. Is that true? Decreases with depth. Is the same in all directions at a given point. Is equal to the atmospheric pressure. No, you see, this option D and option B have no place here. Let's consider the option A and the option C, and to consider which one best describe pressure. Now, the option C is the same at all points in the liquid. No, no, no. It can never be the same at all points. What they are saying is this. The option A is saying this, that if this is a liquid vessel, then inside this is liquid. These are the points where the liquid is filled. Then, assuming I choose point A here, point C, point D, point E, point F, point A. Now that the pressure at point C, at point E, point A, point D, point F, that they are all the same. But that's not what the liquid pressure stated. So the best option is option C, which said is the same in all directions at a given point. So at this point, the pressure is in all directions. That is what liquid pressure is characterized with. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.